Part E. If the slide were not frictionless, determine the work done by friction as the box moved from point A to point B if the speed of the box as it reached point B were half the speed calculated in Part B.
Okay, so for the first thing in this equation, I'm just going to refresh the speed that we found in Part B. So according to Part B, the velocity at B was the square root of 2gh, so we want to account for an equation that's half of that value. So this is the velocity that we're going to be using. And in order to solve this problem, we're going to use conservation of energy again, because the energy is going to have to be the same at point A as it is at point B. So here's what that's going to look like. You're going to have the kinetic energy at point A, and since we've done a lot of equations, I'm just going to go ahead and write the 1/2 mv squared, because by now we know that that's kinetic energy. So 1/2 mv squared of the velocity at point A plus the potential energy at point A, the height is h, is going to equal the kinetic energy at point B squared plus the potential energy at point B. And there's no potential energy, so it doesn't really matter if I put h or y here because there's no height. And then also at point B, after having traveled down this slide of friction, the object is going to have lost energy due to friction, so you have to account for this by subtracting the work done by friction. And in this case, this is the variable we're trying to find, so we want to go about simplifying our equation to get this by itself. So like I said, there is no potential energy at point B because it's at the bottom of the slope, so we can go ahead and cancel that out to 0. And at the top of the slope, it's not moving, so we can cancel the kinetic energy at point A to 0 as well. So I'm going to rewrite that so it looks a little cleaner. And we have mgh equals 1/2 m. I'm going to go ahead and plug in our speed right here. So then we've got 1/2 the square root of 2gh squared minus the work of friction. So what we have is we're going to have mgh equals 1/2 of m times 1/2 squared is going to be 1/4. So we have 1/4, and then the square root and the square are going to cancel out, so times 2gh minus the work of friction. So if we're going to simplify that, this is going to be 2/4, so we want to combine these two constants right here. So 1/2 times 1/2 is going to be 1/4. So we have mgh equals 1/4 mgh minus the work of friction. So we want to get work of friction by itself. So we're going to subtract the 1/4 mgh, which works out because it's the exact same variable. So if we subtract 1/4 of mgh from 1 mgh, we are going to get, this is going to be canceled, and you're going to get 3/4 mgh equals negative work of friction. So we want to divide by -1 here, so that friction is the work done by friction is completely by itself. So our final answer is going to be -3/4 mgh equals the work done by friction if the slide had friction. And that is the end of the problem.